Nothing against root guard, but sometimes you just want a port to be totally shut down if any kind of BPDU comes in because you're just suspicious of any switch. There's not supposed to be a device sending BPDUs in that port, and you just want to make sure it gets slammed shut if any BPDU comes in. And that's what BPDU guard can do for you, because that will put the port into error disabled state. And we know what that means. The port is down, it's down physically, it's down logically, and by default, it must be manually reset. We saw that with port security. Now, using the previous lab setup, I'm going to enable BPDU guard on switch 1's fast Ethernet 0/13 port. If it's been a while since you watched the last video, that's just connected to switch 4. And there should be some BPDUs coming in there about every 2 seconds or so. So let's see what happens. Not many options here. I'm going to go to the interface, and the command is spanning. And just want to draw your attention here to two services that sound a lot alike. BPDU filter is just not a part of this particular curriculum. And I do want to show it to you here, though, because it doesn't send or receive BPDUs. BPDU guard is guarding against accepting BPDUs on the interface. So there is a difference there. Don't enable one when you mean the other, especially here. If we put in BPDU filter, we're not going to get the BPDU guard result. So that's definitely what we want, BPDU guard. And the options are enable and disable. And by golly, that's it. So no fine tuning or anything like that. We get a little message very quickly configured, and then all of a sudden, everything has gone down because, of course, we're getting BPDUs from switch 4 roughly every 2 seconds on that port. That's the hello time. And we see going down. Let's examine the messages one at a time. All we really need is the first part of the message because it's got spanning tree, block, BPDU guard, and the rest of the message will tell you what happened. We received this BPDU on 013. That one has BPDU guard enabled. And here's the most important part, really, disabling the port. Following that, almost immediately, was an error disabled message saying we got a BPDU guard error, and we are putting the interface into error disabled state. Then, as we would expect after that happens, the interface goes down logically, the line protocol. And then finally, the last stage of our port being shut down is the physical state of the interface is now down. Let's review how we can spot that, because of course you might get a call and someone says, hey, we were working with this feature, and then all of a sudden the interface went down, etc., etc. Well, you almost always start your troubleshooting after checking the physical layer with doing some show interfaces, and here is the interface in question. It is physically down, it is logically down, and it is error disabled. Exactly what we expect to see at this point. Now, always you want to resolve the issue before you reset the port with error disabled ports, because the chances are the condition that made it go into error disabled state is just going to happen again. Now, with port security, it might not have happened immediately, but with this feature, it is going to happen immediately, you would think, because the BPDUs are still coming in. So let's say that we go ahead and say, all right, let's just go ahead and reset the port. And we'll do a shut and let the message hit here in a second. There it goes, administratively down. And we do a no shut. And as the port comes back to life, it is going to be sent right back to heck. And there it goes. We got the message interface fast Ethernet 013 change state to up. Well, as soon as it came up, it got the BPDU again that triggered BPDU guard and put the port down. So what you'd have to do in this case is stop those BPDUs coming in on the port before you can reset it. That's what you would want to do anyway, because if you're suddenly getting BPDUs on a port that you never got them on before, something's amiss, something is a tad askew, and you definitely want to check that out. So that is BPDU guard in a nutshell. That's exactly how it works. You know the command, and you know exactly what's going to happen, and that's what happened here. That BPDU came in on 013, and that port went down. Now, remember our old friend port fast? You could configure port fast on a switch port. Especially a good way to use that was when you were having trouble with DHCP, if it wasn't getting the address it needed, the IP address, because it was going through those STP stages. Well, what you can do with port fast is eliminate the listening learning states, and the port goes from blocking to forwarding. And you always got this message about, for gosh sakes, don't have anything connected to it that could possibly cause trouble. Anything except a host. Well, Running BPDU guard with port fast is an excellent idea because if you enable port fast on a port and BPDUs are coming in on it, that means a switch or a like device is on the other end of that connection, and you don't want to have port fast configured on a port that's leading to a switch. So Cisco actually recommends, and I do as well, that if you're running port fast on a port, it's a good idea to have BPDU guard running on it as well. It's such a good idea that Cisco's iOS even includes the capability of globally configuring the router to run BPDU guard on any port fast enabled port. So you don't even have to go to the individual port fast enabled ports to enable BPDU guard on it. You do with this one command, which is spanning port fast BPDU guard default. And that is it. Let me bring something up here. Let's take a look at loop guard because we're going to use a different setup for this. We're going to do a walkthrough on loop guard, and I'll definitely show you the two different ways to enable it, and then one bit of squirreliness, if you will, with loop guard. But first, let's talk about what the heck it does. Here, we're going to have switch 1 originating configuration BPDUs. They're going to both of the switches. No problem at all. Switch 2 is the secondary route. Both ports are in forwarding mode. Switch 1 is the primary route as we'd expect. Both ports are in forwarding mode. The way we eliminate the chance of a switching loop here is on the non-route with switch 3. One of those two ports is going to be in blocking mode, and in this case, it's the one leading directly to switch 2. The one in leading to switch 1 is in forwarding mode. So switch 2 and 3, they're still exchanging BPDUs over on that link. And what can happen is you could have a real problem. That link doesn't have to go down. It could just go unidirectional. And rare, yes, but it does happen. The cable is actually fine physically except for the fact that you've got a unidirectional communication. So A can talk to B, but B can't talk back to A. Or in this case, BPDUs could go from switch 3 to switch 2, but not from switch 2 to switch 3. And that's where this issue would come in. Switch 3 will then wait the duration of the max age timer and then start to transition the port on that link from blocking to forwarding. And when all 6 ports here involved are in forwarding mode, then you're talking about a recipe for a switching loop. So we really don't want that to happen. If we enable loop guard, it would not allow the port on switch 3 in that scenario to transition from blocking to forwarding. What happens is, and here's another mode a port can go into, the port that is no longer receiving the BPDUs will go from blocking to loop inconsistent mode, which frankly acts a lot like blocking mode, but it's not going to go to forwarding mode. So the switching loop is prevented, and once you and I as the network admins fix that cable, the BPDU flow is bidirectional again, the port will actually come back up on its own. So that's another mode to remember though with loop guard. Loop guard will put a port into loop inconsistent mode in that situation. Now we can enable it globally or on a per port basis, and I'll just show you these commands right here. Let's go with the global one first. Spanning and loop guard right there in the middle, and default. Spanning loop guard default is going to put loop guard by default on all of your ports. Now, if you just wanted to enable it on a per interface basis, let's go to a different port. You could go with spanning, and then guard, and then loop. Always watch that guard when you're doing the per port because it's, like you go to spanning and you try to do loop guard or something, or even spanning loop, and it's not going to work. You have to put the word guard first and then either loop, none, or root, and you'll be all set. So the premise under which it operates, straightforward. The commands, straightforward. Here's the part, you were just waiting for that other shoe to drop. Here's the weirdness with loop guard. It's a little odd in this way. You can enable it globally. You can enable it on a per port basis, but it operates on a per VLAN basis. For example, if a trunk is carrying traffic for VLANs 10, 20, and 30, and for whatever reason BPDUs stop coming in for VLAN 10, the port will go loop inconsistent for VLAN 10 only. The port will continue to operate normally for VLANs 20 and 30. So good thing to keep in mind there, but definitely with loop guard, you want to know how to enable it, when it's going to work, and watch that loop inconsistent mode, because of our 3 guards here, we had loop inconsistent, root inconsistent, and error disabled. Make sure you know which guard is going to put a port into which mode. That is it for our guards, but we're moving on to some private VLANs coming up next.